Okay, so here we go. Green Building Calculator, version 2. So the calculator is much more than a calculator. It's a designed decision tool aimed at architects, technicians, surveyors, designers, engineers, specifiers, CAD operators, cost planners, QSs and value engineers, and contractors with the design portion, and energy performance contractors, so they can all do their own number crunching. In order to assess a building, we've got to do a schedule of accommodation. So you put in some quantities, some sizes. It then carries out all of the calculations for areas and volumes. It also allows you to check for protrusions, internal and external temperatures, hours of use. And then we have some option switches to allow us to engage with more and more detailed information on things like roof geometry, protrusion geometry, multiple room sizes, room by room heat losses, multiple glazing of sub-elements. And then with all of this sort of shape information, we can then do a form factor calculation to set carbon targets, and then going a U-value target. So we then go to the U-value calculator, where we choose all of the U-values based on regulations or design standards, including things like air tightness, glazing, embodied energy, embodied carbon set by various bodies. Then choosing which building elements apply to yours, not all of them will, and then just a few double checks on sizes in case there's any additional bits of information that are required. So then we get to the elemental assembly, which is the big U value calculator, which is made up of many component parts, many assemblies, and you have a chance to choose whether they are existing or new products, new components. Choose generic materials or products. It then does the K to U value calculations, and it will check to see whether you have met your targets or not, and warn you if you haven't. In doing so, it engages with insulation K values, decrement delay values, which we're not using at this stage, surface and cavity resistivity calcs. And then in order to populate the elemental assemblies with products, we then need product data sheets for products, accessories, assemblies, glazing, accredited elements by manufacturers. So manufacturers and remanufacturers provide us with data on their all of these products' primary function, where they're applicable in the building, what their performances are, also any embodied energy, embodied carbon, sequestered carbon data sets, and LCA and EPD data sets. Importers and agents and suppliers will provide us with costs for products, costs for accessories, and installers and applicators will provide us with labor sets. So now we have a good set of information on products that we can then start to feed into the calculator, and or we can also get a kind of material average K values for different material groups. But once we have a full list of products, we can then create drop-down lists, which the elemental assembly calculator will interrogate. You choose products by their name, and then it searches using lookup tables, searches the product data sets and populates all of the cells in the calculator. We also have a bill of materials, products, accessories, quantities, labor, and pounds or costs, which allow you to start doing cost planning and getting prices and starting to kind of fill out and make sure that you're heading in the right direction for your client. Elemental cost plan, we don't think we need to do because we're doing a component level cost planning. So that kind of makes the other redundant. And then the same interrogation of data sets will populate the cells for embodied energy, embodied carbon, and LCA. And then outside of the external envelope, we've got the non-envelope elemental assemblies, which might be stairs and kitchens and bathrooms and internal floors, and also external works. Again, all of that data sets interrogated from the product data sheets above. And not only that, but the bill of quantities can also be for tendering and for subcontractors' pricings. There are some elements that we're not going to get out in version 2, thermal break, thermal bridge, condensation, decrement delay, etc. And then we have the summary sheets where we've got elemental building, U values, in-use energy, and percentages for different elements, so that we can see that windows perform very badly, even though they're very high performance, and we can then reconsider whether see whether we need to spend more money on the windows. Fuel choice plus fuel carbon factors equals in-use carbon. The summary sheets for the elements of the building: embodied energy, embodied carbon, sequestered carbon, biogenic carbon, life cycle assessment. And then the final bit of the jigsaw is elemental costs, building costs, pounds per meter squared, fuel costs plus in-use energy equals in-use costs. So we've now got a full set of information so that we can start to do some proper value engineering. And because all the data is populated, we can do instantaneous changes, change any material, any size, any dimension, any temperature, and we automatically get a review of the results all the way through the calculators, all through the many calculators. And that's the presentation, 7.5 minutes.